This is the Airbus A380 passenger airjet, and is in fact the biggest passenger airjet in the world, topping out at 853 passengers in some configurations. This flying city block has an upstairs, a downstairs, a restaurant, a bar, and an elevator. It also has cabins that you can rent to lay down and take a nap. I kind of went on deep end on this whole subject, so I downloaded the manual. What I found was staggering. The Airbus A380 is equipped with 4 Rolls-Royce Trent 900 turbine engines, weighing out at 12,000 pounds each. At a staggering 239 foot long and 262 foot wingspan, she's quite a beast. As you see here, this says this plane holds 85,000 gallons of jet fuel. Really seems like a lot. So I immediately started looking up a jet fuel storage facility. And this is where I started my wormhole. This is a brand new, state-of-the-art, just opened jet fuel storage facility with 3 giant drums of jet fuel right up front. You can see how huge they are. Look at the steps, 100 steps up each one. Let's get a closer look. Upon further examining, we can see this giant drum should be shaped like an airplane wing, because look at the number on it, 168,000 gallons. So that means we could fill 6 of the Airbus A380 airplanes and the entire facility drained. Weird. With the amount of fuel that's held in this airplane, it would take 17 tanker trucks to fill it once. Have you ever saw a tanker truck at an airport? Have you ever saw 17 of them? How about 1? So where's it being held? They've always said that fuel's held in the wings, right? Let me show you how that's not possible. Now, I've told you already that this aircraft is the world's largest aircraft, correct? Yes. So therefore, the world's largest aircraft has the world's largest landing gears. Instead of the typical 2 sets of landing gear, there's actually 4 on this plane. And the outside ones just happen to recess up into the start of the wings closest to the belly of the plane. Now, the landing gear on these are large, you can see, and it disappears up into the wing, taking up most of the available space in the interior of these wings. So that marks that out for fuel being stored there. Now, directly behind, past that, is a giant jacking point for the plane in case you need to jack up the wing for any reason. So it's a solid aluminum piece, and therefore no spot to put fuel there. Right after that, it's an empty area, allegedly, but it's directly behind the first turbine. If you look at a jet's wings, around the front and the back, there are different flaps for various reasons, for slowing and speeding and lifting and dragging the plane. This takes up some of the area also used for gasoline. Let's put this weight of this jet fuel in perspective for you. 85,000 gallons of jet fuel is the equivalent of 578,000 pounds, which also is the equivalent of 1 blue whale on each wing of the airplane. I'm going to show you what that looks like. Weird. It also would be the equivalent of 5 World War II tanks on each wing. Not that much. Or 30 elephants. So, where are they storing this fuel on this airplane? Because when I ask Alexa how big of a container you would need to hold 85,000 gallons of liquid, she says the container would be a cylinder container, approximately 55 feet tall and 35 feet wide. She also went on to say that it would have to be industrially welded and specialized type of steel to hold back such weight. But that's not all. In the manual, there's a breakaway section of the wings and the entire plane. And so this is contradictory evidence, because the wings show that it's only some metal slats, like a skeleton frame, with a thin aluminum composite skin wrapped around it. In the manual, it goes on and on about the water systems. Let me show you how many pages are about the water. It shows everything about it. You can see where it's piped in, all the tanks, where the hoses lead, even the wastewater tanks. But there's only one page about the fuel systems, and it only shows the inlet valves for filling and defilling the plane. Let's get into the turbines a little bit. Internally, these turbines can reach to temperature of 3,600 degrees. Yeah, you heard that right. What type of metals can support up to 3,600 degrees, I thought to myself. So I looked it up. Well, have no fear, our turbines are made from a nickel-based super alloy. What is that, you ask? Oh, well, glad you asked. It's a nickel-based metal mixed with other metals such as cobalt or titanium. That doesn't make sense because I'm going to show you the melting points of nickel right here. And then let's look at the melting points of cobalt and titanium. Now together you could take the median between the two, and that would be about your melting point. The turbines internally can get up to 3,600. That's a problem. So, are you really going to have 3,600 degrees of blasting heat right in front of explosive gasoline? And this isn't a small amount of gasoline. 578,000 pounds. Something's not right here, Airbus. Which one is it? You say your max takeoff weight is 1.2 million pounds, and the empty bare bones plane is 625,000 pounds. Now, if you do the math on the gasoline amount, that's 578,000 pounds. So, aren't we at our max takeoff weight already? We're over it. That's not even adding in people or luggage or carry-on or water or food or personal devices or anything. But there's more. There's also a bunch of grounding points all around the plane. Now, why do you have to ground the plane so much? These are big spots, too. Or the manual says that the plane can be refilled in under an hour. 85,000 gallons in under an hour seems extreme, does it not? Google says that the highest pressure you should be able to transfer liquids is 40 gallons per minute. Now, if you do the math on that, that says that this plane would not take the hour that they say to fill, but instead would take 35 hours. So if it takes 35 hours to fill this plane, how are they flying as much as they are? Airplanes literally land, get deplaned, boarded again, and take off again, over and over and over and over again. They're not waiting 35 hours to get filled. And here's something to think about. Google says that the wings actually flex more than 4 meters during takeoff. With 300,000 pounds of fuel in each of them, they can flex. And one more fun fact. Jet fuel is more explosive with higher altitudes and lower pressure. Follow for part 2.